Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is binomial expansion. Let us learn the important concepts, formula and techniques to solve the questions based on binomial expansion. The wonderful thing about the binomial theorem is it allows us to find the expanded polynomial without multiplying a bunch of binomials together. It turns out that the number of terms in your expanded polynomial will always be one more than the power you're expanding. This is the formula that is very helpful in expanding any binomial. First, let's start with a binomial. A binomial is a polynomial with two terms, which are typically in the format of a plus b the whole square. A binomial coefficient is raising a binomial to the power of n, like so, a raised to n. We all remember that a plus b the whole square is nothing but a square plus 2ab plus b square. But what is a plus b raised to 8? So this is where the binomial formula comes in handy. We are going to apply the binomial theorem for expanding any polynomial. The binomial theorem is the expected method to use for finding binomial coefficients because it is how a computer would compute it. The theorem is a plus b raised to n equal to sigma summation k equal to 0 to n nck or nk, a raised to k, b raised to n minus k. Luckily for us, this formula is the same as another formula, the combinations part. In case if you want any information about the combination, you can refer our previous video. When applying this formula, this expansion, something that may confuse people is how do we work out what a and b are. Well, we have a objects overall and we want to choose b out of them. For binomial combinatoric sum, it helps us to think x taken instead of y, where this one is a is greater than b. Okay, let me explain you by taking an example. Let me first explain you this theorem. We have got a summation notation, the combination formula with factorials and all sorts of exponents. This thing, summation, sigma notation simply indicates we will be adding together a bunch of these. And this thing, n choose k, combinations formula. Hope you would have learned it earlier, where the n choose k combination formula is equal to n factorial divided by k factorial times n minus k factorial. Instead writing this, you can also write this formula directly here so that it will be easy for you to solve the problem step by step. You will not be missing anything. Yes, when you look at this formula, it may look like a lot of process when you first see it, but fortunately it is one of those problems that's very easier in practice than what you look at the formula. But yes, it's probably going to leave you with a full page of math work, which is a bit ironic since this is actually the shorter version than multiplying the binomials out longhand. In binomial expansion, you will be applying starting from 0 to n. Whatever number given, you have to work out till that number by applying this formula. Okay, let's apply binomial on a plus b the whole square, a plus b the whole cube until n. So if you start from 0, replace k by 0 and n is equal to, okay, so nc 0, x raised to 0 minus k, okay, n minus 0, y raised to 0. Any term raised to 0 is just 1. And nc0 is just 1. So x raised to this thing. So let me expand by applying k equal to 0, 1, 2, 3 till n and show you the expansion. Please remember that any term raised to 0 is 1. So I'm not going to mention that separately. And also I'm going to expand this using the combinations formula. When k equal to 0, you'll be getting this term. When k equal to 1, nc1, x raised to n minus 1, y. K equal to 2, k equal to 3. And when k equal to n. Hope you are clear with the binomial expansion for this binomial theorem. Okay, let us now apply the binomial on a plus b the whole square. Now we are going to use the general expansion equation which is saw before. So a plus b raised to 2. A raised to 2 minus 0 plus 2c1, a raised to 2 minus 1, b raised to 1 plus b raised to 2 minus 0. So if we simplify all these, 2 minus 0 is just 2 and 2c1 is just 2, a raised to 1 and b raised to 1 is nothing but b. A raised to 1 is nothing but any term raised to number 1 is nothing but the term itself. Yes, by applying the binomial expansion, we get this formula for a plus b the whole square. Now let's apply the binomial on a plus b whole cube and let's see what we are going to get. when k equal to 0 and when k equal to 1, k equal to 2, k equal to 3. I have expanded for all the terms. Now let's simplify it. If you simplify, you'll get the formula for a plus b the whole cube. Hope you're clear with this one. So this is how we apply binomial on expanding this thing, a plus b raised to n. And if in this case, if particular term say r is asked, then instead of applying the whole expansion, I'm going to give you a direct formula that can be applied to find the rth term. So here is the formula for expanding rth term, or in case if you are particularly asked to find the rth term, you can directly use this formula. You'll be getting questions to find something, particularly fifth term or sixth term, like that. So if that is the case, you can apply this formula directly. Instead expanding the entire binomial expression and finding out that particular term, you can note down this formula and apply this formula directly to find the rth term. Similarly, x plus a raised to n can be expanded as, I'm just giving you like a formula, list of formulas. You can note down one by one. X plus a raised to n is equal to x raised to n plus nc1, x raised to n minus 1, y raised to n. Or in the place of y we have a, no? So write just a. So you can apply this expansion in case of a binomial expansion. If any particular term say r is asked, and then you can, instead of applying the whole expansion, you can apply this direct formula to find the rth term. Now I'm going to concentrate on the combinations formula part of this formula. The last part in the formula is to solve the combinations formula. The obvious way to do this is to apply the combinations formula for each of the problem. But we are going to take a nice little shortcut here using Pascal's triangle. Pascal triangle is nothing but a simple but powerful triangle formed by creating a triangle with 3 ones to begin. Okay, for each row thereafter you simply write ones on both the ends and find the middle number by adding the 2 values from directly above it. I'll show the triangle. Here is the first 6 rows of Pascal triangle. Now here is the good part. Hidden within Pascal triangle are all the answers to choose any and choose k. It is just like a secret little cheat sheet. I'll also show you the diagram which will help you to understand where the hidden n choose k's are located. You can just compare this triangle with that one. Here it is, 0, 0. So you can just compare the Pascal triangle with this one diagram. Now let us see the properties of binomial expansion for x plus y raised to n. There are n plus 1 terms. And the first term and the final term would be, first term would be x raised to n and final term would be y raised to n. Progressing from the first term to the last, the exponent of x decreases by 1 from term to term, while the exponent of y increases by 1 term to term. So on the whole, in addition, the sum of the exponents of x and y in each term should be equal to n. Hope you are clear with this clue. If the coefficient of each term is multiplied by the exponent of x in that term, the product is divided by the number of that term. We obtain the coefficient of the next term. So these are the 4 important properties of any binomial expansion. Here is an example. In this problem, we are going to find the third term in the expansion of 3 plus y raised to 6. This is of the form of expansion x plus y raised to n. So I'm going to apply the formula which I gave you at the beginning of the video to find the rth term. Instead expanding this one using the binomial expansion, we can directly apply the rth term formula to find the third term in the expansion of 3 plus y raised to 6. So here is the formula. The question is asking us to find the third term. So r is equal to 3 and the expansion is raised to 6. So n is equal to 6 here. So the third term of 3 plus y raised to 6 would be, just replace all r's by 3 and n's by 6. So by plugging in, I'm doing the calculation. So I'll be getting 1215 y square. Please check whether you're getting the same value. Hope you're clear with this example. Okay. You'll be getting questions under this topic like find the binomial expansion of this expression, and find the particular term in this expression, and find the coefficient of this expansion, like that. So I'm going to give you one more example in finding the coefficient. So here is the example. Here is an example. Find the coefficient of z raised to 4 in the expansion of 5 plus z raised to 8. So as this is of the expansion is of the form x plus y raised to n. So we are going to apply the same rth term formula. And if you're applying the rth term formula, z raised to 4 will come in fifth term. Am I right? So this question is indirectly asking you to find the fifth term. Hence, we have to find the fifth term of this expansion 5 plus z raised to 8, where r is equal to 5 and n is equal to 8. So whenever you get questions like this, all you have to do is identify which term they are asking, in case if they are asking you to find the coefficient of some particular term. So find what is r, and n is obvious. It is given in the question directly. The exponent is called the n. So just plug in r and n in the rth term formula and find the coefficient of z raised to 4 easily. So by plugging in r equal to 5 and n is equal to 8 in the formula, I think we no need to write the rth term formula again and again. So by plugging in r and n here, we'll be getting this. If you simplify this is nothing but 5 raised to 4 and z raised to 4 times 70. So that would be 43,750 times z raised to 4. Therefore, coefficient of z raised to 4 is nothing but 43750. Hope you're clear with the concept. So this is all. These are the types of questions they will be asking in binomial expansion topic. In case if you have any query regarding this topic, kindly let me know. See